Hey guys, this is Notes 86, and the goal today will be to learn to solve a quadratic equation by taking square roots. Now before we do that, let's just first review what a square root is again. So a square root has this symbol, you've seen it before, and when you find the square root of a number, you can represent that visually if you think about it as a square and finding the area of that square. So for example, if I said the square roots of 16 are blank and blank, hopefully you know that the square root of 16 is equal to 4. And what that means is if I have a square of area 16, that's a 4 by 4 square. So 4 is a square root of 16. But I can also do it this way where I have negative 4 and negative 4. Because negative 4 times negative 4 is still going to be positive 16. So negative 4 is also a square root of 16. So they would both work in this case. I can also think of it in terms of a little equation. So here I could say that 4 squared is 16, and also the quantity of negative 4 squared is 16. So again, these are my square roots of 16. Now if I extend to the next question, what are the square roots of 49? Hopefully you can kind of just see that 49 as a square is 7 by 7, so 7 would be a square root for 9, but also negative 7, because I can square that as well and get a positive 49. If you look over here to your left, if I have 81, the square roots of 81 are 9 and negative 9, because if I think of 81 as a square, it's a 9 by 9 square. But I could also equally find it by putting negative 9 times negative 9 and still getting 81 as a result. So the square roots of 81 are 9 and negative 9. Now you can think of it a different way as a little equation. So if I had a square root squared equals some value, basically I could have this kind of question. The goal today is going to be, how do I solve this little equation? Now before we do that, I do want to review briefly with you guys some different inverse operations. So an inverse means an opposite, and opposites undo each other or cancel each other out. So as a review, the inverse of plus we know is minus. The inverse of multiply we know is to divide. So the inverse of a square is a square root. What that means is, if I happen to have a square in a question, I can undo it by square rooting it. Those two symbols will cancel each other out and then they disappear from the problem. So if I look at this question again here, if I wanted to solve this equation, I want to get this square out, I would take the square root of both sides, and in doing so, when I take the square root, this comes out as x because the square and the square root canceled out. These are gone. So, and then I get plus or minus 5. Again, because 25, if you think about it as a square, is a 5 by 5 square. So the square root of 25 is 5, but I count for both the plus and the minus case. Okay, with that, what happens to the next example? What are the square roots of negative 9? So is that going to work? So can we have a situation where we have a square with an area of negative 9? So if we try it, 3 times 3, would that give me negative 9? And it won't. So that won't work. That doesn't work. What about they're both negatives? If I multiply two negatives, I get a positive. So that won't work either. So in this case, if I have an x squared equals to a negative number and I try to solve it, I really can't find a solution. So whenever you have x squared equal to a negative number and you try to solve it like this means you have no real solutions. So a negative inside of a square root will have some issues for us, and we can't solve it with a real solution. There will be a different way to solve this on the next notes, but for now we'll say no real solution. Lastly, what are the square roots of 0? So again, in this case, the square root of 0 is just going to be 0. because there is no plus or minus 0, so I only have one answer in this case. So to summarize, we have three possibilities here. There are three possibilities. Whenever x squared equals to something positive, you're going to end up having two solutions. Basically the plus and the minus case. For example, if I scroll up a little bit, here x squared equals a positive 25. I end up having x equals plus and minus 5. Those are two solutions. Whenever x squared equals something negative, like in this case here, you're going to have no real solutions. You're going to have no real solutions. And then lastly, whenever x squared equals specifically 0, like in this case over here, you have only one solution, and that one solution will be 0 specifically. Okay, with that, let's go and try some examples together. So example A, let's go ahead and solve this equation. So how do I undo a square? I undo a square with the square root. So when I take the square root, this square root cancels this square. So x comes out by itself. And I have to account for the two solutions, plus and minus, and the square root of 64. Remember, 64 is going to be an 8 by 8 square, so it's plus or minus 8. And I've just solved the quadratic by taking square roots. That is the easiest case we're going to have. That's how that works. Example B. Notice how in this case the negative is outside the square root, so I'm okay with that. In this case, I'm going to first find the square root of 9. That is equal to 3 by itself. This comes down as a negative, so this simplifies to negative 3. Notice how in this case I'm taking the square root, where here it's already kind of in the expression. So here I just simplify to what I see, whereas here I account for the two cases. You'll see this as we move along. Example C. What's the square root of negative 36? Again, from above, if I have a negative and a square root, I really can't handle this situation currently. So whenever you have it in the square root, you'd say no real solutions, and then that would be your answer. So there's that. Lastly, example D. Let's take the square root here to cancel the square. So this square root cancels this square. The x comes out by itself, but I square root both sides. But what is the square root of 0? Well, the square root of 0 is just 0, because there is no plus or minus 0. So in this case, I have one solution, and the answer is 0. So with that, the goal today then is to solve the equation or taking square roots. We can already solve by factoring. We did that the last couple of weeks, and we did it by graphing also. So now let's do it by taking square roots. So how does this work? First, you want to have your quadratic in standard form. What that means is you want to set the function equal to 0 and then get x squared by itself. So in this example here, this is in function notation. So let's change this y into a 0. And then our goal is to solve this equation by getting x squared by itself. So in this case, how do I undo a minus 4? I'm going to add 4 to both sides. So then I get 4 equals x squared. And if you look at your steps, next you want to undo your x squared by taking the square root of both sides. So in this case, I'm going to take a square root of both sides, because the square root, again, cancels the square. So here I get x equals, and I had to account for both the plus and the minus cases, and the square root of 4 is equal to 2. Again, because 4 as a square is a 2 by 2 square. So in this case, I have two solutions, x equals 2 and negative 2. Now, can I verify this on the graph of this same function on the right? So if you look carefully, if x equals 2 and negative 2, notice how on the graph, my graph intercepts at 2 and negative 2, so I feel good about my response. Alright, so there's your notes for today. That's the idea. Now let's practice some examples. I'll do some, you do some, and that'll kind of be it. So example F, we want to solve this quadratic equation, sorry about that, by taking square roots. So notice how I can do this when I don't have this a bx term, because I can get x squared by itself. So in this case, if I solve this equation, my first goal is to get x squared by itself. So I'm going to move this plus 6 with a minus 6 to both sides. So then this cancels out, and I get 3x squared. equals 33 minus 6 is 27. Next, I divide by 3 to both sides. So that cancels out. And I get x squared equals to 27 divided by 3 is 9. So at this point, I've isolated x squared on one side of the equation. Now I'm going to take the square root. So I'm going to square root both sides. Again, the square root cancels out the square. So x equals 2, and I have to account for both cases, plus and minus. And what is the square root of 9? Well, the square root of 9 is equal to 3. So in this case, x equals 3 and minus 3. And I just solved my quadratic equation by taking square roots. Again, pause the video and try example G. Okay, so example G, notice how again, in this case, I can solve by taking square roots because I can isolate x squared. So I can subtract 14 to both sides. 14 minus 14 is 0. I can divide by 2, still getting 0. And I can take the square root at this point because the square root cancels the square. So x comes out and x equals to 0. Again, in this case, I get one solution of x equals to 0. Example H. Now in this case, notice how it's already in a grouping here. So here I already have x squared isolated on the left-hand side. So in this case, I can take the square root. So I can square root both sides at this point, and this square root cancels this square. So in this case, the x plus 5 comes out free and clear. On the right hand side, I have to account for the plus and minus cases, and the square root of 36 is going to be 6. Now in an equation like this, the next step is to undo this plus 5 and move it over to the right hand side. So to undo a plus 5, I'm going to minus 5. Now when you do this, you want to put this minus 5 here to the left of the plus or minus. So you end up getting x equals minus 5 plus or minus 6. Now this is your solution, but you can work it out with one more step. You can separate the plus and minus into a plus and a minus. In other words, I can have x equals to minus 5 plus 6 and x equals minus 5 minus 6. So you can actually find your specific values if you take this plus and minus and you separate it into a plus and then into a minus. So in this case, what is 6 minus 5? Well, that's equal to 1. So there's one solution. Here, what is minus 5 minus 6? That's going to be negative 11. So that's your other solution. So in this case, we solved this quadratic equation by taking square roots. And we found that x equals to 11 and to 1 and negative 11. Example I. Let's solve by taking square roots. So again, the goal is to get x squared by itself. So in this case, how to undo a plus 25? I can subtract 25 to both sides. So that cancels. So I get x squared equals minus 25. And at this point, when x squared is isolated, I can take the square root. So I'll square root both sides. So the square root cancels the square. And x equals the square root of negative 25. But we just mentioned that when we have a negative and a square root, we can't really address that right now. So whenever you see that, whenever you see this negative and a square root, you can stop and say x is no real solutions, and that will be your answer for something like that. Okay, example J and K are very similar, so I'll show you J, you can try K. So again, let's solve this equation. Let's try to get x squared by itself. So in this case, I need to move this 3 to the other side first to get this x squared, which is in a group right now, by itself. So I can divide by 3 in this case first to both sides. So this 3 gets moved. So I'm left with x minus 5 squared equals to 6, because 18 divided by 3 is 6. At this point, the x squared is isolated. It's all grouped together. So now I can take the square root of both sides. And when you do this, two things happen. This square root cancels this square. In this case, x minus 5 comes down. Also, when you take the square roots, you have to account for the plus and minus cases of the square root of 6. Now the square root of 6 isn't a perfect square, so it's not going to simplify out any further than that. So this is also okay. You can leave the answer in this form as well. But I want to now solve this for x. So to finish, how do I undo a minus 5? I can add 5 to both sides. When you add or move this constant, you want to move it here to the left-hand side of the plus or minus. So you get x equals 5 plus or minus square root of 6. And in this case, that would be your answer. You can leave it that way. So you could say x is 5 plus radical 6, 5 minus radical 6. Or you can leave it with the plus minus like this. That is still 2 solutions. Pause the video and try example K. Alright, so example K. Again, the first thing here is to divide by 2 to move this 2 to the other side. So I can do that pretty easily. Negative 32 divided by 2 is negative 16. And then here I can take the square root, so if I take it to both sides. Notice how in this case I can work out the left-hand side very much the same. But here I get the square root of negative 16, which we, at this point, when you have a negative inside the square root, we can't deal with that, so we end up saying here x equals no real solutions. Again, there'll be a way to solve this on our next notes, but for now we can say no real solutions, and that's an okay answer. Okay, so now to wrap up today's notes, the question next is, it says seeing structure. So can you solve this quadratic by taking square roots? That should be taking square roots. And if you look at it carefully, actually pause the video, think about this for a second, and we'll come back. Okay, hopefully you thought about it for at least a few seconds. If you look at this carefully, if you were to set this equal to 0, so if you had 2x squared minus 9x minus 5 equal to 0, could you get x squared by itself isolated? And if you look at that, you can move this 5 over, but as you start to work, you're going to end up having 2 different x's here. And so it's going to be hard to isolate x by itself. So in this case, because you have, sorry, let me just make color. Because you have a bx term like that, you wouldn't want to use taking square roots, this technique in this question. So for questions that have an x term in it like this, you would opt to use a different technique like factoring or graphing or something else. So when you take square roots, you really want to have an x squared isolated, and you don't want to have an x term by itself like this. This will really hinder this technique. So beware of that structural piece when you solve by taking square roots. You do not want an x term by itself. Alright guys, one last question, which is an application question here. So here it says a squirrel is in a tree holding a chestnut at a height of 46 feet, so above the ground. Sorry, let me fix that. So it's 46 feet above the ground. So here's the squirrel. We'll just put a little dot. Actually, we'll put it on this side. So it's 46 feet above the ground. So from here to the ground, it's 46 feet. And then it says it drops the chestnut, which lands on the top of the bush that is 36 feet below the squirrel. So if this chestnut falls 36 feet from where the squirrel is at, then basically this bush is 10 feet high, which is a pretty high bush. So this is at 10 feet. And then it says, here's the function that represents the situation. When will the chestnut reach the top of the bush? So notice how the top of the bush is 10 feet above the ground. So in this question, we want to find out the time for when this is at 10 feet above the ground. So for your height here, for this height, we're going to replace it with 10, because that's the ending height for where the chestnut stops, which is the top of the bush. So we're going to have this equation. We're going to have, this will be at 10 equals negative 16t squared plus 46. And now I have a quadratic equation, and notice how there's no t term, only a t squared term. So I can solve this by taking square roots. So I'm going to first subtract 46 to both sides. So I get negative 36 equals negative 16t squared. Next, I'll divide by negative 16 to both sides. So that cancels. So I end up getting negative 36 divided by negative 16. But a negative divided by a negative is a positive, so I get 36 over 16. So I get 36 over 16 equals t squared. At this point, having t squared isolated, I can take the square root of both sides. So remember, two things happen. The square root cancels the square, and then I have to account for the plus and minus cases. Now in this case, notice how 36 and 16 are both perfect squares. So the square root of 36 is 6, and the square root of 16 is 4. So I can simply reduce this down to be plus or minus 6/4, which, if you think about it as separate values, first off, 6/4 is the same as saying 3/2. So I can leave it as plus 3/2 and minus 3/2. Those are my solutions. But in this case, it represents time or seconds. So because this is going to be in seconds, you have to think about this making sense in real life. So can the chestnut take negative 3.5 seconds to fall? And it can't, because I can't have negative time. So in this case, this answer, even though I can compute it, is extraneous. It doesn't really count. So the actual answer to this question is it takes 1.5 seconds for the chestnut to fall 36 feet to the top of the bush. Guys, with that, with this new block schedule, here's the deal. You only have one note every 2 days. So this is for today and also for Tuesday. If you feel like you need more practice, you can watch more of the video below, which is these other 8 examples of solving by taking square roots. It's just extra practice if you want to see more examples worked out. I'm going to just pause the video, work them all out for you. You can check it as you need. And then your next lesson will be on Wednesday, April 22nd. So it'll be one video for every 2 days starting today. Alright guys, so go ahead and pause it. When you come back and play, you have all the extra questions worked out, and that'll kind of be it. Alright guys, so if you tried some of the extra questions, here they are fully worked out for you. Notice how you get into the second 4 questions, so 5, 6, 7, and 8. Do you see how in 6, 7, 8 they're a little bit bigger? Remember, the whole goal is to get x squared by itself. So number 6, this minus 6, first have to move to the right by adding 6. And then as you do the work, notice how here, when you subtract this 5 over, you end up getting negative 5 plus or minus 7. Now that's an okay answer, but you should be able to simplify to the actual numbers by splitting the plus and minus into a plus and into a minus. So for example, negative 5 plus or minus 7 is the same as saying oh, I made a mistake there, guys, sorry. It's the same as saying negative 5 plus 7 and negative 5 minus 7. I just caught myself with an error, sorry about that. So it's like saying negative 5 plus 7, which will be 2, and then negative 5 minus 7 is negative 12. So you can separate the plus and minus to get your 2 solutions when that occurs. So it happens in number 7 also, and also in number 8. So notice how I did that here for you in the work. Pause the video. Guys, your next set of notes will have more of the same kind of questions, so if you're not quite clear yet, you'll see it again on our next video for a second take at this note. Alright, with that, have a good day, and I'll see you guys on Wednesday.